So section 6.4, assessing normality. So the distributions you have seen up to this point have been assumed to be normally distributed. Okay. But how do you determine if that's a reasonable assumption to make or not? Okay, so one way is to take a sample and look at the sample to determine if it's reasonable to assume that that sample data came from a normal population. So again, we're kind of heading into inferences here. So we're taking what we saw in the sample data to try to draw an inference about the larger group or the entire population. So how do we do that? So here are some guidelines that are used to help make this determination. So the first thing is to make a histogram. And for a normal distribution, the histogram should be roughly bell-shaped. Now remember, a histogram is actually a bunch of rectangles, and so by bell-shaped, we've got these rectangles that kind of stair-step up and stair-step back down. So we've kind of got this unimodal and symmetric distribution going on. For small samples, though, this is not very accurate, and another method is needed. Okay, the histogram of the sample data may not look normally distributed, but the sample still may have come from a normally distributed population. But for a small sample, we just didn't get enough representatives from that population to see that happening in the histogram for that sample data. The second thing that we need to do is we need to check for outliers. So for a normal distribution, there shouldn't be any outliers. So one way to check for outliers is to use a modified box plot. So these are two graphs that we actually learned how to make back in Chapter 3 for quantitative data. And so on the modified box plot, the outliers are the values that are shown as dots outside the rest of the values. The new plot that we get in this chapter is something called a normal probability plot or a normal quantile plot. And this plot is provided through statistical software on a computer or a graphing calculator. So we're going to look at both. So we're going to look at how to make them in StatCrunch and how to make them on our TI-84. And this particular plot is designed such that if the points lie close to a line, the data come from a distribution that's approximately normal. If the points do not lie close to a line, or they show a pattern that's not linear, the sample data are likely to come from a population distribution that's not normally distributed. So these technology boxes are similar to ones that we got back in Chapter 3, with the exception of now for the histograms, we're just gonna, because we're just doing kind of a quick check for a shape here, we're just gonna let the calculator or StatCrunch itself just pick an automatic bin width, without calculating one and forcing it to use that. So in StatCrunch, we would again enter the data into a column in the spreadsheet. We would click Graph and Histogram. But then in that pop-up window that appears, we would select the column of data that we want, and we could give our graph a title, but then we're just going to click Compute. Okay, in this case, we are not going to enter a value for the bin width or tell it where to start the bins at. We're just going to let the program choose both of those values for us. The same thing on the TI-84. If we push Stat1 to get into the spreadsheet for lists and enter the data into L1, and second function y equals where we went to the stats plots menu to make box plots and modify box plots back in Chapter 3. Again, we would push 1 to select plot 1. So back in that chapter, we did not make histograms on the calculator because it's kind of a real pain in the butt to use a specific bin width and so on, and trying to make all of those fit into the calculator view screen. But in this case, we're just going to use Zoom 9, and we're just going to let the calculator automatically pick a bin width and a place to start those bins at as well. So Zoom 9 is the feature that we're going to use there. Okay. All right. The other thing that we learned how to make back in Chapter 3, and this is identical in steps to what we did in Chapter 3 to make a modified box plot. So again, in StatCrunch, we would click Graph and Box Plot, and we would just make sure that we check the box next to Use Fences to identify outliers. On the calculator, there are two box plots on the screen. The one that has the little dots after it is the modified one, and that's the one that we want to identify outliers with, versus the fifth graph that's here is the normal box plot. So we want the modified one. So in that list of graphs, it's the fourth graph that's there. And again, on the calculator, you can push trace and arrow left and right to see what the values of those outliers are if the graph shows outliers. Okay, so the new graph for this section is something called a normal probability plot. Now on StatCrunch, that is called a QQ plot. So under graph, we would pick QQ plot from that list. Again, we'd select the column of data we want. And then we're going to check the box next to normal quantiles on the y-axis. This isn't necessary, but it does make the graph that you get in StatCrunch look the same as the one that you get on the TI-84 versus if those axes are reversed. Under graph properties, we give the graph a title and click Compute. On your TI-84, this graph is the same place as the histogram, the box plot, and the modified box plot. It's just that this one now is the 6th graph on the screen here. So there's 6 graphs listed there. The 3rd one's the histogram, the 4th one is the modified box plot, the 5th one's the box plot, and this last one here, the 6th graph, is the normal probability plot. And again, on the calculator, we use Zoom 9 when we're making stat graphs.